Hello, and welcome to this basic machine learning case study from the Corporate Finance Institute. My name is Andrew, and I'll be walking you through this course. I have worked in software engineering and data science for a number of years, gaining practical experience in building machine learning models to solve real business problems. Machine learning models are used to make predictions and recommendations using data. From the algorithms that power your Netflix recommendations, to models that use X-ray images to predict lung disease, the applications of machine learning are broad. In this course, we'll use Python to build a particular type of model called a classification model, which we will use to predict if a customer is likely to default on their loan payments. This information is important because it can be used to inform risk calculations and pricing decisions. Machine learning is not as scary as it sounds. We'll be using many of the skills that you learned in our Python fundamentals course to load, clean, and explore our data. We'll then use a technique called feature engineering to modify and improve our data so that it's more useful for our analysis. Once we've prepared the data, we will then build and evaluate two basic but popular classification models. The two models we'll look at are logistic regression and random forest, which are essential skills building blocks for machine learning. Finally, we'll look at how to evaluate the accuracy of each model, as well as how to improve the performance using techniques such as class balancing. We're going to start from the very basics and walk through every line of code in short, digestible videos. I'll also challenge you with exercises to practice and test your skills along the way. Predictive analysis is very exciting and constantly evolving, which is why machine learning courses like this form part of our business intelligence and data analysis certification. With this course, you'll be armed with the end-to-end experience of how to implement a machine learning model in Python from scratch. So, let's get started.
Machine learning is a technique that helps us to make predictions by identifying patterns in data. There are two main types of machine learning. Supervised machine learning helps us understand how a given variable is related to other variables in our dataset. We usually start with a defined question. For example, how do these variables affect this outcome? Or in our case, how do the loan and customer characteristics affect the likelihood of loan default? Our model can predict how likely a loan default is, or classify them into buckets of default/non-default. Supervised machine learning is the most common approach used in business. Unsupervised machine learning is a little different. Again, we start with a dataset of what we think is related data. The difference is that this time we don't have a specific question in mind. We are hoping that the model will tell us how data is related. In this course, we'll be creating a supervised machine learning model. More specifically, we'll be creating a binary classification model, which is essentially trying to answer a yes or no question. We'll use both logistic regression and random forest classifiers to answer, is a given loan going to default or not? Now, let's just take a closer look at the specific scenario that we're dealing with. Financial institutions incur significant losses due to default of loans. By modelling the risk of loan defaults, such institutions can make more informed decisions about loan applications, and this can be used to inform pricing decisions and price according to a particular risk of an application, or to calculate more informed risk evaluation of the institution's loans as a whole. In this case study, we'll be looking at a dataset of vehicle loans issued in India, and our task is to use customer credit scores, previous loan history, and socioeconomic factors such as age and employment to predict if each customer will default on their loan. Hello. Before we get on to our practical demonstrations, I'd just like to give you a kind of quick intro video to show you through the course materials so you know where to find all of the different resources that we have provided. Now, first things first, you can see I have downloaded my course materials into a folder on my desktop. And if we take a look inside that folder, you should find kind of 3 subfolders. The first one is data, the second one is notebooks, and the third one is supplementary. And in addition to these 3 folders, you should find the theory slides that go along with our practical demonstrations. So if I take a look inside the data folder, you should find several CSV files. The vehicle loans file is our raw data that we'll be working with. In addition to that, there are several iterations of the vehicle loans data that we'll create at the end of each chapter. I have just included them here in case any of you have problems completing any of your notebooks. And then in addition to the data files, we have the data dictionary, which contains a list of all the column names in our vehicle loans data, along with a brief description of what they contain. So you can use this to refer to as you complete the exercises, just to give you a bit more context about the data. Now, the second folder we have is notebooks, which contains a list of all our chapter notebooks. You've probably noticed that there are solution and student notebooks available for each chapter. The student notebook is the empty wireframe notebook that you should use to follow along with the videos. And the solution notebook contains all of the completed code that we will show you throughout our demonstrations. And you can use this to refer to if you get stuck on anything or are unable to complete any of the exercises. Now, if I use Anaconda Navigator just to quickly boot up an instance of Jupyter Notebook, and then I'll go into Desktop and into my course content folder and finally into the notebooks folder. I just want to show you what the kind of first student notebook looks like. So inside each of these student notebooks, you will find a kind of mix of text and code cells. The code cells will be left empty for you to fill in as you follow along, with the exception of the imports at the top, which we will provide for you. So you'll just follow along with the videos and fill out these cells as you go. There should be a useful comment to indicate what you should type in there. Of course, you can add and remove cells as you please. This is not strict, but it is helpful for you to follow along in the structure that we have laid out. One thing I'd just like to point out is that if at any point our demonstrations instruct you to save data, as long as you follow the file path that we provide for you, then any of your additional saved data will go into this data folder, and you should see it here. Now, the last thing I just want to talk about is the supplementary material, which you can find in the supplementary folder. And what this is slides that contain a mix of the theory and some of the code from the notebooks. And the idea of these is to provide you with a quick reference material so that if at any point during or after the course, you just want to quickly remind yourself of something you have learned, you can jump into the supplementary material and extract a piece of code or refresh some theory. That's all for now, so why don't we go ahead and start our theory lessons. This course will be divided into 8 separate chapters. The introduction has given us a brief overview of machine learning and of the case study we'll be working with. From this point onwards, you'll be working in Python, so the first thing we'll do is learn how to load and clean the data. Then you will use exploratory data analysis to perform simple statistical comparisons and identify initial patterns in the data. Moving on to this, we'll go to feature engineering, which is really just a fancy term for modifying data. And this will help us to make the data more analysis friendly. After this, you will learn how to build a logistic regression model to classify each loan as likely to default or not default. Once we've built this model, we'll use evaluation metrics and the ROC curve to decide how good the predictions are. After this, you will construct a different classification model the random forest, before looking at ways to improve model accuracy using class balancing. Once you've covered this content, you'll have walked through a basic machine learning cycle from start to finish. You should start to understand how these techniques can be applied to other scenarios and how we can reuse Python code to make our work much faster.
Continue learning. Join CFI today.